So in this example, we're going to take what we looked at with those first couple of slides and apply that to looking at specific polynomial functions. So in question A, we have that f of x equals 3x minus 5. This function has a degree of 1 since there's a 1 exponent on the x, and the degree indicates the maximum number of x-intercepts. So we could have possibly one x-intercept. We will always have one y-intercept on a function. The end behavior, a graph will actually help this out, even if it's not accurate. We have a degree 1, which makes a line. Looking at the leading coefficient of 3, that's a positive leading coefficient, meaning this graph will move up from left to right. So our end behavior, this graph starts down in quadrant 3 on the left and moves to quadrant 1 on the right. And something we didn't talk about before is the number of turning points. These are the points where the graph actually turns around and changes direction, moving up or down. Since this is a line and it continually moves up, we have no turning points. B, our function is f of x equals negative 2x squared minus 4x plus 8. It's a degree 2 because of the negative 2x squared. Means we have two possible x-intercepts, a maximum of two x-intercepts. Every polynomial function will have one y-intercept. Quick sketch of the graph. It's a degree 2, which makes it a parabola. And since the leading coefficient is negative 2, that parabola will open down. Looking at it this way, on the left side, this begins in quadrant 3, and on the right, it ends in quadrant 4. The number of turning points, like I said, with A, this is the number of places where the graph changes direction. There is 1. It is right here. It changes the graph from moving up to moving down, so we have 1 turning point. Looking at C, most complicated of the functions, 2x cubed plus x squared minus 2x minus 10. This is a degree 3 polynomial, so we could have a maximum of 3 x-intercepts. We will always have one y-intercept. The end behavior, it's a degree 3, so it loops around in the middle. And we have a positive 2 for the leading coefficient, so that means it moves up from left to right. So the graph will look something like this. Looking at turning points, we have one right here and a second one right here. So we could have 2 turning points. I know I skipped over end behavior, but that's okay. 2 turning points. End behavior, looking at the left side in quadrant 3 and the right in quadrant 1.